Hey guys, today we talked about the Pythagorean theorem, how we use that to find missing side lengths, what that looks like. So let's apply it, let's use it. We're going to use the Pythagorean theorem to find the missing side length of each right triangle and round to the nearest tenth if necessary. So remember, in Pythagorean theorem, our legs are what create the right angle, so A and B. I could switch that order. It doesn't matter which one's A, which one's B. Hypotenuse is our longest side. Remember that this says A squared plus B squared equals C squared. And so we substitute our values in. So A is 3, so 3 squared plus B is 4, 4 squared. That should equal C squared. Okay, we have 9 plus 16. Could use Desmos if needed. Equals C squared. 9 plus 16 is 25. That's C squared. We just want C. The inverse of squaring a number is to take the square root. That's always the last thing you want to do to find the side length. Because remember, a square root finds the side length of the square. So this is going to be 5. So our missing measurement is 5. Okay, let's do it again. All right, so longest side is my hypotenuse. The other two sides are what create the right angle. Okay, so we have A and B. A squared plus B squared should equal C squared. Okay, so I'm going to put 24 squared plus 7 squared should equal C squared. All right, if you don't know your squares, we can jump into Desmos. All right, so I have 24 squared is 576. And then 7 squared, if I don't know it, I can go to Desmos, it's 49. Should equal C squared. It's important to keep that square there. Do 576 plus 49, that's 625. Is C squared, but remember the last thing, because I don't want C squared, I just want C. So we square root that and find out what is our answer. So if I square root, then I get 25. Okay, so 25 is my missing side length. Okay, over and over, that's what the pattern is. So I need to be able to identify the legs that make up the right angle and my hypotenuse. So I have A squared plus B squared equals C squared. I keep writing that, training my brain what that order is. 12 squared plus 7 squared should equal C squared. So this time I'm just going to go into Desmos and I'm going to do 12 squared plus 7 squared is 193. That equals C squared. The last thing is take the square root because we don't want C squared. We want to know the side length. Okay, so square root of 193. Again, I can just hop into Desmos. Okay, and so I find out, oh, hey, it's a decimal, 13.89, so I'll round that to 13.9. Would be my hypotenuse. So just substituting in, but you have to know what your legs are and you have to know the hypotenuse. Okay, so now let's look, and this time it's a little different. So this time we're given a leg, we're missing the other one, but we have the hypotenuse. It's still the same thing. We're going to plug in what we know, except there's just a little bit more work we're going to have to do, right? So I have 5 squared plus B squared. And if you don't like having B stay there, I could always make this B and this is A, because we don't want to mix it up as like a 6. So if that helps you, like that. C is 13 squared. So I've just plugged in the values, right? Let me clear this up a little bit. Okay, and remember with the legs, it doesn't matter. I like when I'm missing a leg, it's nice to replace the b just because it's really easy to mix that up with 6. All right, so a squared plus 25 equals 169. If you don't know that, hopefully you do. If you don't, you just go into Desmos. Okay, a squared's not by itself, so I have to subtract 25 from both sides this time. So I get a squared equals, if you don't know, I'm just going to use Desmos really quick. 169 minus 25 is 144. All right, that's a squared. So that's like if I had the square out here, that area is 144, but we want to find a, so we have to do the square root of that, and a is going to equal 12. A, you could go into Desmos if you're not sure. That's one you should know, but if you don't know, now you know what you can do. All right, so let's do it again. So here's my right angle, okay? So I'm missing a side length, and I have the hypotenuse. So a squared plus b squared equals c squared. I'm going to say a squared plus 6 squared equals 10 squared. A squared plus 36 equals 100. And again, if you are not comfortable with those squares, you go into Desmos, do 6 squared. Okay, we need to subtract, so we get a squared alone. Then you take the square root. Okay, so a, because remember, we just want the side length, not the area, would be 8. Okay, over and over, that's the pattern. So find your right angle. There's your 2 legs. This is your hypotenuse. Okay, a squared plus b squared equals c squared. Keep telling myself that so it's in my brain. Right, substitute, I don't know, a squared. B is 16, so 16 squared equals c is 24 squared. All right, so those are some big numbers. So I would go into Desmos. I need 16 and 24 squared. So 16 squared is 256, and then 24 squared. Okay, so 256, 576. I want to subtract, get a squared alone. So practicing like equation solving, right? All right, so 576 minus 256 is 320. And then we use the square root to find out the actual side length, because a squared is the area. We want the side length. So I just go back in. I say, okay, square root of 320, 17.888, so I'm going to round that to 17.9 would be my missing side length. Okay, so that's how you use Pythagorean theorem. It's substitute in, square, and then take the square root. Do I need to subtract, or can I just add them and then take the square root? Okay, let's look at stories here. We have a rectangular pool at Andy's gym that measures 25 meters by 50 meters. I like just creating visuals here. So 25 by 50, here's his swimming pool. How many meters would Andy need to swim in order to swim diagonally across? So diagonal is corner to opposite corner, right? So we're looking for what's that distance? That's the hypotenuse, okay? All right, so a squared plus b squared equals c squared, recognizing how you set that up. So 25 squared plus 50 squared equals c squared. I love it. They're on the same side, so I'm going to go into Desmos. I'm going to do 25 squared plus 50 squared is 3,125. Okay, so right now we found the area of this whole rectangle. We don't want that. We just want the side length here. So we're going to take the square root so that we can find what is that distance across right there. Okay, so I'm just going to come into Desmos and do square root of 3,125. and I get 55.9 is my distance approximately. Okay, it's not super precise, but it's approximate because that's not a perfect square. Okay, but that's how far he would need to swim across. He needs to swim 55.9 meters. Okay, let's look at it again. A pole vaulter rested a 17-foot pole against a wall. Okay, so I'm just going to start creating my picture. So here's the wall. I rested my 17-foot pole against it. If the top of the pole hit the wall at 14 feet above the ground, so 14 feet above the ground, so that's telling me this height is 14 feet. Okay, how far from the wall is the bottom of the pole? So I'm trying to figure out this distance right here. Okay, and drawing the picture helps me see what all the pieces are. There, I'm missing a side length. So this a squared plus b squared equals c squared. So I don't have one of my legs, I have the hypotenuse and another leg. So a squared plus 14 squared equals 17 squared. Okay, a squared plus 196, if you don't know, type it in. 17 squared, I don't know that off the top of my head. So 17 squared, 289. I need a squared alone, so subtract what's with it. So I get a squared equals 289 minus 196, 93. But I don't want the area. I want to know the square root. I want to know that distance on the ground, right? That's what I'm trying to find out. So square root of 93 is we'll say 9.6. So it's 9.6 feet from the wall. Okay, so using Pythagorean theorem, that's what it's all about. How do I use this? What would I use it for? Okay, what's the area of the largest square? If we know the area here, if I want to know the side length, I take the square root, and that's 6. I have the area, I want the side length, so I take the square root, that's 8. Okay, so if I want this, first I need to know the side length, so that then I can figure out the area. But I can also area. Remember, a squared plus b squared equals c squared. Remember, these represent area already, and the area of the small plus the area of the other one should equal the area of the largest. So I already have areas right here. So 36 plus 64 should equal the area of the large one. Oh, hey, 100 equals c squared. That's as far as I go this time because I want the area. This represents area. If I took the square root, I'd be finding the side length here. Okay, so sometimes we overcomplicate it. What is it actually asking for? All right, one more example. If the area of square 1 is 25 units and 2 is 16, what is the perimeter? Ooh, so lots of juicy stuff in here. All right, so I would know square root, this is 5. Square root of this is 4. So a squared plus b squared equals c squared. So I have, and I could already go like a squared equals 16. Oh, plus 16 equals 25. A squared equals 9. Square root that. So we get a equals 3. Okay, so that's the side length. Perimeter means there's 4 of those. So perimeter is 3 times 4, which would be 12. Okay, that's what we do. Pythagorean theorem.